Good morning. Today we're going to look at solving rational equations. This is section 8.6a, and we're going to look at two different types of equations that you might come across. A rational equation contains at least one rational expression, so an algebraic fraction. You can solve a rational equation by clearing out the expressions in the denominator. So one caution here, always check for extraneous solutions. These are solutions that that we found correctly, but when we plug them back in, they don't work. They end up having us trying to divide by 0. So we do want to always look for those restrictions. What would make the denominator 0? The first type of equation that you're going to see is what we call a proportion, where we have a single fraction equal to a single fraction. So strategy 1, if you have two fractions set equal to each other, we can just use that cross multiplication process and solve from there. So we do have a single fraction equal to a single fraction here. So we are going to multiply this top to the opposite denominator. And then we're going to do the same thing on the opposite diagonal. We're going to take the 2x minus 1 and multiply it to that 3. And then those should be equivalent. So here we just have some distributing to do. We get 5x plus 10. On that side, other side, we end up with 6x minus 3. And now we just have a basic linear equation to solve. So we're going to get our x's to one side. And then we're going to get our constants to the opposite side. So we end up with x equaling 13. Now, we're going to go back and check, was there anything that would make our denominator 0? Since all of our denominators here were just plain constants, we didn't have anything to worry about. So this should be our correct solution. We can always plug it back in for x into both spots and double check that it works. All right, for our second one, same thing, we're going to cross multiply. So go ahead and pause the recording and try to get this one set up and solved, and then turn it back on when you're ready to check. All right, checking our answer. We should be multiplying 7 to x plus 1, and on the opposite side we're multiplying that 2 and the 2x minus 4. Distributing, you should have had 7x plus 7, and on the opposite side 4x minus 8. Combining like terms, getting everything to the same side here for our x's, we end up with 3 of them. And then getting our 7 to the other side, we end up with 3x being negative 15. So then dividing x would be negative 5. And again, we did not have any variables in the denominator to worry about, so we should be okay with that answer. Checking it. If we put a negative 5 in here, we have negative 5 plus 1 would be negative 4. Divided by 2 is negative 2. On the opposite side, we get negative 10 minus 4, which is negative 14. Divided by 7 is also negative 2. And since those are equivalent, it is the correct answer. All right, the second type of equation that you are going to be working with is when we have some fractions in our equation, but not single fractions on each side. So you'll see some plus and minus signs in here. That tells us that we have to look at strategy 2. So if the rational pieces of our equation are being added or subtracted, then we have to multiply every term of the equation by the least common denominator. This should eliminate any fractions, and then we have a basic equation to solve. So looking at these denominators, we have an x, a 5x, and a 1. Our LCD in this case would need to be a 5 and an x. All right, now, one option that they showed you in Algebra 1 was just to create a 5x for all of your denominators. We're actually going to use this other process where we multiply by the LCD, and it's going to completely eliminate our fractions. All right, so we are going to multiply every single term by 5x. Okay, now I put a 1 under that so we can see numerators versus denominators. So when I go and distribute this, I'm taking 5x times 1 divided by x. Those x's are going to cancel each other out and leave me just a 5. When I distribute it to the next piece, again, I'm taking 5x times 6 divided by 5x. Now the whole 5x is going to cancel out and leave me with just a 6. When I distribute it to that final term, which is just a 1, I'm taking 5x times a 1, and I get a 5x. Okay, so again, I've turned this into an equation that's very basic, easy to solve. We're going to subtract our 6 over, and then divide out our 5. So we end up with x being negative 1/5. Okay, now looking at our domain restrictions. From our original problem, in both of these cases, we would say x can't be 0. Since we're not coming up with that for our solution, this should be a valid solution. Okay, second example. We need an LCD. We have a 6, a 2, and a 6. So for the numerical part, my LCD would need to have a 6. Looking at my variable part, I have an x squared, an x, and an x squared. I need that highest power, so I need an x squared. So I'm going to multiply every single term by 6x squared. Okay? When I distribute it to the first one, those 6x squareds are going to drop out and leave me just a 1. When I distribute it to the second fraction here, some of it's going to cancel out. The 6 and the 2 could reduce to a 3. The x squared and the x would reduce to a single x. And when I multiply it to this 1, I still just have a 3x. For the second part, or the second part of this side, distributing that 6x squared to 7 divided by 6x squared, again, the 6x squareds are going to drop out and leave me just a 7. So I have 1 equals 3x plus 7. I'm going to subtract the 7 over. I now have 3x equals negative 6, and when I divide, x would be negative 2. Once again, looking at my LCD restrictions, in all these cases, I would just have to say that x cannot equal a 0. So this should be a valid solution, since I'm not getting 0 for an answer. All right, my third example here. My LCD, my denominators are a 5r, another 5r, and just a 1. So my least common denominator would be 5r. So I'm going to times everything by 5r divided by 1. When I distribute to that first one, 5r times r minus 4 over 5r, the 5r's drop out. We just get r minus 4. When I distribute it to this next fraction, 5r times 1 divided by 5r, the 5r's drop out, I'm just left with a 1. When I distribute it to just a 1, 5r times 1 is 5r. All right, again, solving this, we're going to get our r's to the same side. We're going to get our constants to the opposite side. And then we are going to divide. So r equals negative 5/4. Again, my domain restriction, r cannot be 0. So this should be fine. All right. Our last example here is a word problem. It says, do you work in a pharmacy that mixes different concentrations of saline solutions for its customers? The pharmacy has a supply of 2 concentrations, a 0.5% and a 2%. The function y equals 100 times 0.02 plus x times 0.005, all divided by 100 plus x, gives the concentration of the saline solution after adding x milliliters of the 0.5% solution to 100 milliliters of the 2% solution. So let's kind of analyze this equation for just a minute. We are taking 2%, which would be our decimal 0.02, and we want 100 milliliters of it. So that's going to give me the amount of saline in that 100 ml quantity. Then I'm adding an unknown amount of milliliters to a 0.5%, which would be a decimal of 0.005. And then my total volume would be 100 plus that unknown amount that I'm adding. Okay, so that's where the equation comes from. Now it says, how many milliliters of the 0.5% solution, 0.5% solution, must we add for the combined solution to have a concentration of 0.9%? Okay, so that 0.9% is going to be my final y value. All right, now again, we have to convert to decimals. So 0.9% would be 0.009. The rest of my formula looks like this. All right, now what I have here is really just a proportion. If I put a 1 under here, I have a single fraction equal to a single fraction. So this is back to that first strategy where we can just cross multiply. Okay? But be careful here because we're multiplying this whole thing, we're multiplying this whole thing. So 0.009 times 100 plus x should equal 1 times that, which is nice because multiplying by 1 isn't going to change anything. So we have 100 times 0.02 plus x times 0.005. Okay, let's go ahead and distribute. 0.009 times 100 times me by 100 is just going to move my decimal back to the right 2 places, so I get 0.9. Distributing it to the x, I get 0.009x. On the other side, 100 times 0.02, again, it just moves my decimal 2 places, and I end up with a 2. Multiplying my x, I get 0.005x. Okay. We need to get variables to one side, so let's go ahead and subtract our smaller x piece over here. That leaves me, sorry, I have a plus sign here, 0.004x, and on this side all I have is the 2. Then I can subtract the 0.9. So 0.004x equals 1.1, and then when I divide 1.1 by 0.004, I end up with 275. So this is saying that I need to add 275 milliliters of that 0.005 or 0.5% solution. Okay? And that's going to dilute it down from 2% down to 0.9%. All right? Let me know if you have any questions.